Meow.
That is not Schrodinger. I'm sending John over.
Schrödinger's cat is a famous thought experiment that tries to illustrate the weirdness of quantum mechanics. Erwin Schrödinger was one of the founders of quantum mechanics. He's the guy who came up with the equation that tells us how quantum mechanical systems evolve through time. But like Albert Einstein, Schrödinger actually wasn't completely comfortable with the implications of his own ideas. He worried that quantum mechanics wasn't the complete description of nature. So he invented this thought experiment to illustrate how bizarre it could be. One of the things about quantum mechanics is that a system can be in a superposition of two different possible things that it would look like if you were to look at it. So an electron could be spinning clockwise or counterclockwise. Quantum mechanically, it could be both at the same time until you see it. Schrödinger invented a clever experiment. He has a Geiger counter that sets off an alarm, that smashes a bottle of poison. All of this is in a box with a cat. There's only a quantum mechanical probability that that actually happens. The poison fills the box and kills the cat. And Schrödinger points out if you take quantum mechanics seriously, it says that after this, the cat is in a superposition of half alive and half dead. The point of this is supposed to be no one really thinks that real cats are in superpositions of alive or dead, but that's what quantum mechanics seems to say. Today we would say, you know what? Yes, that is what quantum mechanics seems to say. Cats can be in superpositions of alive or dead. You don't ever see it because real-world cats are constantly being monitored by the environment they're in, by the atoms in the room, by the photons of light bouncing off of them. This collapses their wave function. So once you open the box, you're only ever going to see a cat alive or dead. But the rules of quantum mechanics allow, in principle, for a superposition of both.
And besides, for Einstein to think that entanglement was too spooky to be real is just, it's dumb.
Einstein, dumb. Does not compute.
How many bell tests does it take? Jeez. But, hijo de la gran... Entanglement cannot be the answer. It has too many syllables.
The idea of entanglement is at the heart of quantum mechanics. It was really Einstein who appreciated this because he didn't think that quantum mechanics was the whole story. And he, like Schrödinger with his cat, was trying to give a thought experiment to show how weird it was. You can imagine an electron. It's either spinning clockwise or counterclockwise. But now imagine two electrons. They could both be in a superposition of clockwise and counterclockwise, but an entangled superposition so that we know they're both spinning in opposite directions. If you were to measure one and it says clockwise, you know the other one is counterclockwise, even though you don't know ahead of time what either one of them would be doing. Einstein didn't like this. He thought, how could it be possible that I have a particle here, I measure it, and that changes the state of a particle over there? So this is a thought experiment he put forward in a famous paper in 1935 called the EPR paper, Einstein, Podolsky, and Rosen. Since then, people thought about it and they said, well, can we wriggle out of it? Can we invent some way that there's a hidden variable, a hidden piece of information that tells us, if you measure this particle, what that other particle is going to do, to avoid the problems of quantum mechanics and entanglement? So the physicist John Bell proposed a test, an experimental way to tell whether quantum mechanics was right or not. He said, if quantum mechanical entanglement is the way the world works, there will be certain correlations when you send these particles far away that you can't explain away by imagining there's hidden information attached to each particle. We've done these experiments. They're called Bell tests. And what we find is that quantum mechanics is right. So not only is entanglement real, it's been demonstrated in the lab, there's no simple way out of it by doing an Einsteinian trick, adding a bit of information at every particle.
Dios, papá. Wait a minute. EPR without Papa is ER. Einstein-Rosen. An Einstein-Rosen bridge?
An Einstein-Rosen bridge is just a fancy way of saying a wormhole. 1935, the year Einstein, Podolsky, and Rosen published the EPR paper about entanglement, Einstein and Rosen, without Podolsky, also published a paper on a completely separate topic where they invented the idea of wormholes, which we sometimes call an Einstein-Rosen bridge. A wormhole is just a shortcut through space-time, a little tube that connects one part of the universe to the other. And when they were inventing them, they were just doing classical general relativity, but what you get at the end of the day is a little connection between two parts of the universe that should at least remind you of quantum entanglement. These days, modern physicists are saying it doesn't just remind us of that, maybe they're the same thing. If you really believe that the world is quantum mechanical at its core, everything in the world, including the curvature and geometry of space-time, should be explained by quantum mechanics. So modern physicists have proposed ER equals EPR. A connection via a wormhole in space-time can be thought of as quantum entanglement between these two regions. And not only that, but all the different ways that geometry of space-time shows up, the gravitational force you feel, is a result of quantum entanglement. At the end of the day, it's really quantum mechanics that determines the shape of the universe.
OMG, you are such a nerd.